When you think of air traffic control, you probably have this image, right? A tower watching planes land and take off. But what about on the water? Well, that's where Vessel Traffic Services, or VTS, comes in. Think of it as the digital watchtower for our busiest ports and harbors. So, what's the tech that keeps these enormous ships from causing total chaos? Let's get into it. In rooms that look just like this, operators are basically the unseen conductors of a massive symphony of steel and water. But how in the world do they do it? What kind of technology gives them that all-seeing eye they need to keep global trade chugging along and our waterways safe? That's really the question we're going to dig into. So it all starts with one simple thing: being able to see. We're talking about the core sensors that have to find and identify every single vessel out there, whether it's day or night, rain or shine. Let's break down the first big tool in the kit. The foundation, the bedrock of all of this, is radar. It's the system's most basic sense. And what's really crucial here is that it's a non-cooperative system. Now, that's just a fancy way of saying it sees things whether they want to be seen or not. It's actively pinging, sending out radio waves to find anything and everything. You know, at its heart, the process is actually beautifully simple. An antenna sends out a little pulse of energy. That pulse hits a ship, bam, and bounces right back. The antenna catches that echo, and a computer does the math, instantly plotting the ship's position and speed as a dot on the screen. Transmission, reflection, reception, processing. It's this constant, reliable loop that really forms the backbone of all maritime awareness. So radar's superpower is that it sees everything, even ships that aren't talking or maybe don't want to be found, but it does have an Achilles heel. You know, heavy rain can create a mess on the screen called clutter, and big islands or buildings can create shadow zones where it can't see. But its biggest weakness? It tells you that something is there, but it can't tell you who or what it is. To the radar, it's just a dot. Okay, so to solve that who is it problem, we add another layer, the Automatic Identification System, or AIS. Now, unlike radar, this is a cooperative system. Ships have a transponder that's constantly broadcasting a stream of data, basically telling the world, hey, I'm over here, this is my name, and here's what I'm doing. And this is where the magic really happens. That anonymous radar blip on the screen is suddenly transformed. With AIS data fused right in, the operator doesn't just see a dot. They see the vessel's name, its size, where it's going, and its exact course and speed. The picture goes from being a ghost on the screen to this rich, detailed profile. This table really sums it up perfectly. Radar is active. It's out there looking for things, so it sees everything, but it's totally anonymous. AIS is passive. It just tells you who it is, but it relies on the ship actually cooperating and having it turned on. They are really two sides of the same coin, and when you put them together, you get this incredibly powerful system that both detects and identifies. But just seeing the ships isn't enough, right? To truly manage all this traffic, an operator needs more context. They have to be able to talk to the vessels, and they absolutely need to understand the environment that those vessels are in. So these are the system's other crucial senses. The most direct tool, of course, is the good old VHF radio. It's the lifeline. This is how operators give instructions, share critical information, and confirm what a captain is planning to do. Now, it's not perfect. Channels can get really congested, and language barriers are a real thing, but it is still an absolutely essential direct link. Then, for that final layer of ground truth, you just need actual eyes on the scene. Imaging systems, everything from standard CCTVs to thermal and infrared cameras, let an operator visually confirm what all the electronic sensors are telling them. You know, is that vessel actually turning? Is that smoke coming from the engine room? A camera gives you that instant, unmistakable answer. And of course, a ship isn't moving in some kind of vacuum. The environment is always changing. So VTS systems are constantly pulling in data from anemometers for wind speed, tide gauges for water depth, and sensors for things like current and fog. All of this is absolutely critical for predicting how a vessel is going to behave. Okay, so this brings us to a huge challenge. I mean, think about it. We have radar data, AIS data, camera feeds, nonstop radio chatter, and constant weather updates. How can one human being possibly track all of that at the same time without being totally overwhelmed? Well, the answer lies in the system's brain, what we call decision support tools. This is the software that takes all of that raw, chaotic data and transforms it into something clear, prioritized, and, most importantly, actionable. And this is the solution to that information overload problem. Decision support tools, or DSTs, take every single one of those data feeds, radar, AIS, weather, and fuse them into one single coherent picture. But they don't just display the data, they're constantly analyzing it in the background, looking for trouble. The real power here is that the system can kind of see the future. It's constantly calculating trajectories, flagging potential collision risks, or setting up an alert when a vessel wanders out of a shipping lane. It lets the operator be proactive, not reactive. But, and this is a really big but, it's not a perfect system. Too many false alarms can lead to alarm fatigue, where people just start ignoring them. And over-reliance is a real danger. That's why they're called support tools. The final call, that critical human judgment, still rests with the operator. So, where do we go from here? The maritime world is changing incredibly fast, and this digital watchtower has to keep up. Let's take a quick peek at what's just over the horizon. The future is all about making these systems even smarter. You've got AI and machine learning coming in to make those predictions even more accurate. Imagine augmented reality that could overlay vital data right onto an operator's view of the harbor. And then there's the biggest game changer of all, autonomous vessels. How does VTS manage a harbor filled with a mix of human-crewed ships and self-sailing ones? Which really brings us to a final, pretty thought-provoking question. As the ships themselves get more and more intelligent, the role of that VTS operator is going to have to change. It really makes you wonder, in the harbor of the future, who is truly in control? The human in the watchtower or the algorithm at sea?